Ma'am,
Good evening, sir.
good evening, ma'am. Continuation of the paper discussion. Which of the over 1 minute? 1 minute. Yeah. Which of the following statement is true? If pressure and temperature are increased at equilibrium in the reaction, two X, which is a solid, plus Y2 is a gas, giving you 2XY, it's a gas, and delta H is negative. Delta H is an exothermic reaction. When it's negative, it means it's exothermic reaction. So this question is based on Le-Chatelier's principle. Le-Chatelier's principle. So Le-Chatelier's principle states that when a constraint or a stress is applied on the system which is in equilibrium, the equilibrium, when a constraint or a stress is applied on a system which is in equilibrium, the equilibrium shifts either to the left or to the right in order to nullify the effect of the stress. Nullify the effect of stress. Now, this system is in already equilibrium. And clearly the question says the reaction is exothermic because delta H is negative. When the reaction is exothermic, the system gets heated. So therefore, this reaction favors at low temperature. So if the question here, if you see the number of moles, this solid is not considered. Now, here we have 1 mole of gaseous reactant, but here we have 2 moles of gaseous product. 2 moles of gaseous product. So product is the gaseous, the pressure is what? More, because the gaseous products we have 2 moles. So low, this it's already exothermic and the pressure is high in case of products. Now this kind of reactions will favor at low temperature and also at low pressure, decreasing the pressure. But here they say if pressure and temperature are increased, if the pressure and temperature are increased at equilibrium, this equilibrium will shift towards the left. When we say this equilibrium shifted towards the left, it means the products will undergo decomposition to give back their reactants. So the backward reaction will be predominant. So because the temperature is high, so decomposition of the product will take place. Hence the answer for this question is option 2. The reaction will proceed in the backward direction. Next question. The solubility product of AgCl in pure water is 1.0 into 10 to the power minus 10. What is the solubility of AgCl in 0.1 molar HCl? What is the solubility of AgCl in 0.1 molar HCl? Now, AgCl is a 1:1 electrolyte, or it is 8:B type electrolyte, because this AgCl will dissociate to form one positive ion and one negative ion. Number of positive ion and negative ion is equal in number. So for this type of electrolytes, KSP will be equal to solubility product will be equal to solubility of Ag plus into solubility of chlorine. They've given the solubility product as 1.0 into 10 to the power minus 10. That is equal to, they're asking solubility of AgCl in 0.1 molar NaCl. This 0.1 molar NaCl will dissociate to give 0.1 molar chlorine because it's a strong electrolyte. Therefore, we take solubility. The concentration of chlorine is 0.1. So on simplification, yes, we will get this part. This we can write 10 to the power minus 10 will be equal to S into 10 to the power minus 1. So S will be equal to 10 to the power minus 10 divided by 10 to the power minus 1. It will be 10 to the power minus 9. Hence, 1 into 10 to the power minus 9. Therefore, the answer for this question is option 1. The next question, for a reaction A giving you B. For a reaction A, which is a gas, gives you B, which is also a gas. At equilibrium, they are in equilibrium. The partial pressure of B is found to be 1/4. Partial pressure of B is found to be 1/4. Partial pressure of B is found to be 1/4 of the partial pressure of A. The value of delta G naught is the value of delta G naught. We know that delta G naught is equal to minus 2.303 RT log of K. This can be written as RT minus RT natural log of K. Natural log of K. So K is written as whatever is on the right hand side, we have write it from the numerator, and whatever is on the left hand side, we write it from the denominator. So products B is on the numerator. In terms of pressure, they're asking partial pressure of B divided by partial pressure of A. That will be equal to minus RT natural log of. They say clearly B is found to be, partial pressure of B is found to be 1/4 the partial pressure of A. So partial pressure of B is 1/4 the partial pressure of A. That is PA divided by 4 into PA. So what happens now? That will be equal to minus RT natural log of 4. Plus, no, 4 goes to numerator, will be plus. So option will be 1. So the next question. Heat of combustion. Heat of combustion of carbon is minus 394 kilojoules per mole. The magnitude of heat evolved in the combustion of 6.02 into 10 power 22 carbon atoms will be. So carbon on combustion, the product what we get is carbon dioxide. And they say the amount of heat liberated is minus 394 kilojoules. They're asking the magnitude of heat evolved during the combustion of 6.022. Now carbon, this is 1 mole. So 1 mole is 6.022 into 10 power 23 carbon atoms. 6.022 into 10 power 23 carbon atoms on combustion gives minus 394 kilojoules. Minus sign indicates it's exothermic. It's not a negative value. Kilojoules per mole. Now, if 6.022 into 10 power 23 carbon atoms are combusted, so it's a cross multiplication. 6.022 into 10 power 23 into 394 divided by 6.022 into 10 power 23. So this will be 10 times. This is 22 and this will be 10 times. So it will be minus 39.4 kilojoules. Minus 39.4 kilojoules. There is no option with minus sign. This minus sign, I told you, it is the amount of heat liberated. So therefore, the amount energy liberated, this minus sign indicates is exothermic, but the energy released is 39.4. Therefore, the answer for this question is option C. The next question, NLM values. NLM values of an electron in 3p orbitals are. Now you should remember N is principal quantum number. It can have a value 1, 2, 3 and goes on like this. This is principal quantum number. Principal quantum number. Now azimuthal quantum number. This azimuthal quantum number represented by letter L, it have a value 0 to n minus 1. As per the question here, they're asking this 3py. Now 0 to n minus 1. Here from this value, we understand n is equal to 3. Principal quantum number is 3. When principal quantum number is 3, azimuthal quantum number is 0 to 3 minus 1. That is 0 to 2, 0, 1, 2. If L is 0, it is S sub shell. If L is 1, it is P sub shell. And L is 2, it is D sub shell. Now, the next is magnetic quantum number. This magnetic quantum number is represented by letter M. It has a value minus L2 plus M. Now, when we say P, this is from minus 1, 0, plus 1. Minus 1, 0, plus 1. Now, they're asking Py. So Py will have minus 1 value. M will have minus 1 or it will have plus 1 value. Minus 1 or it will have plus 1 value. Now, therefore, the answer is N is 3, L we found out it to be 1, M can be plus 1 or M can be minus 1. Here also same. So therefore, the answer here is option 3, both. It can be either option 1 or option 2. Next, complex. What the complex given is cobalt complex, CO, NH3 5 times, ANO2 and Cl2. Can show only ionization isomerism, only linkage isomerism, both ionization and linkage isomerism, and linkage and coordination isomerism. Now, this molecule CO, NH3 5 times, NO2, Cl2, we also can write it in other way, CO, NH3 5 times, ONO, ONO, and Cl2. Here, this is a linkage isomers. It's a linkage isomers. Why it's a linkage isomers? Here, the donor atom is nitrogen. Here, the donor atom is oxygen. NO2 is an ambidentate ligand. Ambidentate ligand. So a ligand which has more than one type of donor atom will be called as ambidentate ligand. Therefore, it can show linkage isomers. Now, this molecule, you also can write CO, NH3 5 times, Cl, NO2, and Cl. So it can undergo ionization to form NO2 minus and this is plus. So they also can show ionization isomers. Ionization isomers means compounds having same molecular formula, but they undergo different ions and different ions when dissolved in water. Therefore, this complex can show both linkage as well as ionization isomers. The next one, lanthanides. It's lanthanum. Lanthanum, when hydrolyzed, we get lanthanum hydroxide, Ln. When we hydrolyze, we get lanthanum hydroxide. Plus X. What is this X? X is now lanthanum. Water, we can write it as H and OH. H plus and OH minus. Now, if we balance the equation, we get lanthanum hydroxide. If we take 2 moles of this, 2 moles of this, you get 6. 6 moles of water if we take. And plus, you get 3 moles of hydrogen. The gas liberated is hydrogen gas. X is hydrogen. Therefore, the answer for this question is option 3. The next question, match the purification process given in column 1 with the metals in the column 2. Now, polling is a process of purification or refining copper. Copper metal is refined with polling. What is polling? Molten copper is stirred with green logs of wood. Green logs of wood. When this is stirred with green logs of wood, the hydrocarbons present in the wood will reduce any oxides of copper to its copper, pure copper. So this is polling. Polling is done for purification of copper. Next, cupellation. Cupellation is a process of purifying silver. Silver is purified by a process called as cupellation. Liquation. Liquation is used to purify tin because tin has lesser melting point than the impurity or the gangue. Since the metal has lesser melting point than the impurity, it can be purified by a process called as liquation. And next is Van Arkel process. Van Arkel process or method, it is also called as vapor phase refining. Vapor phase refining. It is done for zirconium. Zirconium and titanium are purified by Van Arkel process. And Mond's process, you should remember, Mond's process is for nickel. This is also an example for vapor phase refining. Hence, the answer for this question is option 1. A is Q, B is R, C is zirconium P, and D is, C is tin, and D is P, zirconium. Therefore, the answer for this question is option 1. Which of the following statement is incorrect about silicones? R2SiCl2 and RSiCl3 are monomers of silicones. Silicones are hydrophobic. Yes. R3SiCl is used to stop polymeric chain. Polymer of SiO4 4-. Which of the following statement is the incorrect statement about silicones? polymers of SiO4 minus. This is a wrong statement about polymers. The answer is option 4. The next question, assertion. First electron gain enthalpy of all element is positive. Successive electron gain enthalpy of all element is negative. Assertion and reason are true, and reason is correct explanation of the assertion. Both assertion and reason are true, but reason is not correct explanation for the assertion. Assertion is true, but the reason is false. Both assertion and reason are false. The first electron gain enthalpy of element is positive. This is a wrong statement. Successive electron gain enthalpy of the element is negative. This is also a wrong statement. Both assertion and reason are false. Hence, the answer for this question is option 4. The next question, partial hydrolysis of XeF6 is XeF6 on hydrolysis. Partial hydrolysis. It gives XeOF4. This further undergoes hydrolysis to form XeO2F2. This further undergoes hydrolysis to form XeO3. So partial hydrolysis of XeF6 gives xenon oxyfluoride and XeO2F2, XeOF4 and XeO2F2. Hence, the answer for this question is option 1, oxyfluorides. They are called as oxyfluorides. Next question, given below are two statements. The product of reaction of phenol with bromine depends on the nature of the solvent. Reaction of phenol with bromine in chloroform gives monosubstituted bromo derivative, whereas the reaction of phenol with bromine water yields tri-substituted bromo derivative of phenol. In light of all the above statements, choose the most appropriate answer from the above. Now, the product of reaction of phenol with bromine depends on the solvent. Very true. Now, phenol, when allowed to react with bromine in carbon tetrachloride, we get two products. We get orthobromophenol and we get parabromophenol, because OH is orthoparadirecting, OH is electron donating. But the same reaction, if phenol is allowed to react with bromine water, so we get only one product. We get only one product. We get bromine here, we get bromine here, and also we get bromine here. We get 2, 4, 6 tribromophenol. This is a white precipitate. It's a white precipitate. Now, the product of reaction of phenol with bromine depends on solvent. Here the solvent is carbon tetrachloride, here the solvent is water. Therefore, the statement 1 is true. Reaction of phenol with bromine in chloroform or carbon tetrachloride gives monosubstituted. This is orthosubstituted and this is para-substituted derivatives. Whereas the reaction of phenol with bromine water, you can see here, you get 2, 4, 6 tribromophenol. So both the statement 1 and statement 2 are right. So therefore, the answer for this question is option B. Both the statement 1 and statement 2 are correct. The next question, match the following: alletane, sucralose, saccharin, aspartame. Now, alletane is the highest sweetness. So A is P, that is true. Sucralose, stable at cooking temperature, that's also true. Saccharin, first popular artificial sweetener, that's also correct. Aspartame, stable at low temperature. The answer for this question is option A, or 1. So all the answers are correctly matched. Consider the following reaction sequence and predict the product B. Predict the product B. The answer for this question is option 3. The answer is option 3. We get this molecule. The B, the product we get is C2, CH2, CH3. That is ethyl benzene. The product we get is ethyl benzene. This is Friedel-Crafts acylation. Now, benzene we can write like this. When this is allowed to react with acetic anhydride, CH3, C double bond O, O, CH3, C double bond O, and this is O. CH3, C double bond O, O, CH3, C double bond, this is O. So what happens is the bond breaks here. This hydrogen attacks this oxygen, and this carbon attacks this oxygen. So we get C6H5, C double bond O, and CH3. We get acetophenone. This is called Friedel-Crafts acylation because the catalyst what we use is anhydrous aluminum chloride. This, when we allow it to react with hydrazine, NH2 is hydrazine. Now, second is with hydrazine. When we allow it to react with hydrazine, we can write H2N NH2. So what happens? This H2O gets eliminated. So we get a benzene ring, we get C double bond N NH2, and we have a CH3 group. This, when we allow it to react with aqueous potassium hydroxide, followed by C2, that's ethylene glycol, CH2OH, the product, major product we get is ethyl benzene. Ethyl benzene. This is B. The answer for this question is option 3. Ethyl benzene. The next question. A sample of 0.4 grams of organic compound was treated according to Geldar's method. The ammonia evolved was observed in 50 ml of 0.5 molar sulfuric acid. Ammonia evolved was observed in 50 ml of 0.5 molar sulfuric acid. The residual acid requires 60 ml of 0.5 molar sodium hydroxide for neutralization. The percentage composition of nitrogen. So the percentage composition of nitrogen, we have to calculate. Now, what is that they've given? They've given weight of the organic compound. They've given the weight of the organic compound as 0.4 grams. So for sulfuric acid, sulfuric acid, the normality of the sulfuric acid or normality of sulfuric acid is M into N, molarity into N, because it's a dibasic acid. So 0.5 into 2, it is 1. So the concentration of sulfuric acid is equal to normality into volume. That is 1 into 50 ml of sulfuric acid. 0.5 molar. 0.5 molar is 1 norm. So likewise, concentration of sodium hydroxide is N into V. Sodium hydroxide concentration is 0.5 into 60. This is 5 and this is 30. So amount of ammonia neutralized will be equal to 50 minus, this is 50, it's not 5, 50 minus 30. So 20 ml of sulfuric acid will be left out. So when 20 ml of sulfuric acid is left out, we can find percentage of nitrogen by the formula 1.4 into normality into volume of the acid divided by weight of the organic compound. So that will be equal to 1.4, normality is 1, volume of sulfuric acid is 20 divided by 0.4 weight of organic compound, that is 70%. The answer for this question is option 3. Next question. The number of reaction steps for the formation of the following product. Number of reaction steps for the following formation of the following product. It's a complex reaction. We have a cyclo compound. This, when it's acidified, we get a compound like this. So this is positive charge, you get 1, 2, 3, 4, and 5. This undergoes rearrangement to form this compound. This on hydrolysis will get a compound H and H. This further decomposes to give a product like this. This is the product. So here in this, the number of steps involved is 1, 2, 3, and 4. The answer for this question is 4 steps. Next question. 10 grams of a piece of marble. Marble is calcium carbonate, was put into excess of dilute hydrochloric acid. When the reaction was complete, 1120 ml of carbon dioxide was obtained at STP. The percentage of pure calcium carbonate in the marble is. So calcium carbonate, the reaction also they've given. Calcium carbonate on reaction with HCl gives calcium chloride, water, and it gives you carbon dioxide gas. So they clearly say 1,120 ml of carbon dioxide is liberated. So number of moles of carbon dioxide, is given as 1120 ml divided by 22,400, because molar volume is 22,400. That is equal to 0.05 moles of calcium carbonate. 0.05 moles of calcium carbonate. Therefore, what is the weight of calcium carbonate? Weight of calcium carbonate is 0.05 moles, 0.05 moles into molecular mass of calcium carbonate is 100. Therefore, it will be 5 grams. So percentage purity is given by the formula 5 grams by 10. Initially, we are taking how many grams of calcium carbonate? That's marble 10. 5 divided by 10 into 100. So this will be equal to 50. So the purity of calcium carbonate is 50%. The answer for this question is option 3. The next question. The following compressibility factor versus pressure, which is true? Which is true? At high pressure, gas B behaves as non-ideal gas. At moderate pressure, B behaves as an ideal gas. At moderate pressure, the gas A behaves like ideal gas. At moderate pressure, C behaves like an ideal gas. So the answer for this question is option 1. At high pressure, gas molecules will be very close to each other. Therefore, gas B will behave as a non-ideal gas. So non-ideal gas will not have force of attraction. All right. So when pressure is very high, the molecules will be close to each other, and therefore they can be liquefied. So they behave like a non-ideal gas. Hence, the answer for this question is option 1. Next question. The pH value of 0.1 molar solution of sodium acetate, formic acid, ammonium acetate, sodium hydroxide, and HCl. The pH value of 0.1 molar solution will be of the order. Sodium hydroxide is a very well-known base, will be high. Therefore, it will be 4. 4 greater than sodium acetate. Sodium hydroxide, sodium acetate, when it's dissolved in water, you get formate ion and sodium ion. This formate ion will react with H+, and OH minus ion of water will react with NaOH. So NaOH is a strong base. Here also pH will be greater than 7. So next is option 1. This is greater than 3. Ammonium hydroxide is a base. So it is 3. 3 is stronger than formic acid. Formic acid is 2. And that is stronger than that is higher, the pH is higher than 5. As HCl is an acid, the pH will be lesser than 7. So the sequence is option 2. The next question. If temperature increases, solubility of the gas decreases. For this situation, which of the following statement is are correct? Reaction is endothermic. Le-Chatelier's principle can be applied. Both statement 1 and statement 2 are incorrect. Statement 1 is correct. Statement 2 is incorrect. Statement 1 is incorrect. Statement 2 is correct. So reaction is endothermic. If temperature increases, solubility of gas decreases. For this situation, the following statement are correct. So this is a wrong statement. Reaction is endothermic. And Le-Chatelier's principle can be applied. So this is option 3. So the test paper is done here. So we have learned many test papers. So you should be in a position to write the NEET exam. Now, we have few more minutes time. I just want to give a brief synopsis of the chapter called as chemical equilibrium. In chemical equilibrium, you should know if I write A moles of A plus B moles of B giving you C moles of C plus D moles of D. It's a reversible reaction. For a reversible reaction, equilibrium constant K can be written as, in terms of concentration, we can write concentration of C to the power C, concentration of D to the power D, divided by concentration of A to the power A into concentration of D to the power. So when you write equilibrium constant for a reaction which is in equilibrium, whatever is on the right-hand side, you write it on the numerator, raising the coefficients to their power. Whatever is on the left-hand side, write it in the denominator, writing the coefficients to their power. But if the same reaction is in terms of pressure, we write equilibrium constant in terms of partial pressure. So this will be equal to partial pressure of C to the power C into partial pressure of D to the power D divided by partial pressure of A to the power A into partial pressure of D to the power D. This is in terms of partial pressure. Now, you also have to remember the relation relation between Kp and Kc. Kp will be equal to Kc into RT to the power delta N. Now, what is this delta N? Delta N stands for number of moles of gaseous product minus number of moles of gaseous reactant. So only gas molecules has to be considered. Gas molecules has to be considered. They can ask you at what condition Kp becomes equal to Kc. When delta N is equal to 0, Kp becomes equal to Kc. They can ask you examples also. You should know this. And likewise, when Kp will be greater than Kc, when Kp is less than Kc, or when delta N of gas molecule is greater than 0, it means it is positive. It is positive. Then Kp is greater than Kc. When delta N of gaseous is less than 0, delta N of gas molecules is less than 0, Kc will be greater than Kp. So you need to remember this. Now coming to the other concepts here, relation between standard free energy change and equilibrium constant. You should remember this form. Delta G naught is equal to minus 2.303 RT natural, log to the base 10, sorry, log to the base 10 of K. Or we can write this as minus RT natural log of K. Log to the base, natural log is nothing but log to the base E. This formula you should remember. And in chemical equilibrium, we were talking about Le-Chatelier's principle in this. At different conditions, on increasing the temperature, what happens? Pressure, what happens? That's to be learned. Now, in case of ionic equilibrium, we need to learn acid concept, Arrhenius theory, Bronsted and Lowry theory, Lewis concept of acid and base. So these three concepts we need to learn. According to Arrhenius theory, an acid is a chemical substance. Acid is a chemical substance which produces H plus ion when dissolved in water. When dissolved in water. So likewise, base is a chemical substance which produces OH minus ion when dissolved in water. Now, for an example, if we take HCl and dissolve it in water, we get H plus and Cl minus. Likewise, NaOH when dissolved in water, we get Na plus and OH minus. Anything gives OH minus when dissolved in water is a base. Anything which gives H plus when dissolved in water is an acid. This is according to Arrhenius theory. Now, according to Bronsted-Lowry theory, what is an acid? Bronsted-Lowry theory. According to Bronsted-Lowry theory, acid is proton donor. H plus donors are called as acid and base is proton acceptor. Proton acceptor is called as a base. Now, for an example, if we take HCl and put it in water, dissolve it in water, H plus will be donated to water. Therefore, we get H3O plus and Cl minus. This is called as hydronium ion. It's called as hydronium ion. Since water accepts a proton from HCl, water is called as a base. And HCl donates a proton, therefore, HCl will be called as an acid. Likewise, if ammonia is dissolved in water, H plus will be donated by water to ammonia. NH4 plus and OH minus gives you ammonium hydroxide. Here, water is donating a proton, therefore, water acts as acid. Ammonia accepts a proton, therefore, ammonia acts as a base. Now, from these two equations, we can understand water is acting as an acid as well as a base. Since water is acting as an acid as well as a base, it is called as ampholytes. It is called as ampholytes. Chemical substances which can behave both like acid and also like a base is called as ampholytes. Ampholytes. Now, the next one is conjugate acid-base pair. Now, what is this conjugate acid-base pair? Conjugate acid-base pair. So, acid-base pair which differ by one proton is called as conjugate acid-base pair. Acid-base pair which differ by one proton is called as conjugate. So, if you take an acid and if you write its base HCl, it's an acid. So, in order to write its conjugate base, remove H plus. So, we'll get a Cl minus. Now, if the base is given, assume that the base is given SO4 2 minus 10. I need to write its conjugate acid. Add H plus. When you add H plus, we get HSO4 minus. So, if an acid is given, its H plus ion is minus to form its conjugate base. If a base is given to write its conjugate acid, we need to add H plus ion. The next is we have Lewis concept of acid and base. Lewis concept of acid and base. Electron pair acceptor is called as an acid. Electron pair donor is called as a base. According to the Lewis concept, electron pair donor is called as an base and electron pair acceptor is called as an acid. So we will continue the next questions, next set of questions. Next. Thank you.